Good afternoon. My name is Caitlin Green, and this is my vlog from the lecture that we had this past Tuesday, September 14th, 2021. In last time's lecture, we discussed Chapter 4, and in Chapter 3, it was going over the central tendency, or the median, mean, and mode of a set of numbers. But in Chapter 4, we went over how spread out the data was, or the variability or dispersion of the data. The reason that we went over this is because, say if you have two different sets of data, they can share the same median, which does cause some issues whenever you're trying to compare data. However, the distribution can be greater or more spread out between the two different sets of data, which is why it's important to consider both the dispersion and the 3 M's whenever you're looking at data. So my first question was going over what the semi-quartile range was, and you briefly explained that, how it's just the first and third quartile on the graph. And simply, if you were to draw the data like I did on my notes here, the semi-quartile range is just the 25% mark and the 75th% mark of the data, which I knew that from school, so I guess I was just kind of overthinking it. But we also went over the difference between the rational formula and the computational formula. And while the rational formula, like you said, is a bit more of a rational way to approach it, and it makes the most sense, you did say that the rational formula was not dependable because sometimes you could get two different numbers, just because the formula leaves a lot of room for error. And so you recommend that we use the computational formula, which honestly kind of made the same sense to me, which is good because the computational formula is the one that's more reliable. But we went over data that we had found in Chapter 3 to find what the standard deviation would be. And then we went more into the different types of standard deviation. How we had, of course, the standard deviation, which was, you said, was the unbiased sigma, and I believe that that type of standard deviation is what I used whenever I was in high school, but the formula for that is the square root of the sum of squares divided by n minus 1. And then we also went over the actual standard deviation, which was found by SD, and that formula was square root of the sum of squares divided by n. And as we did find, whenever we use the two different equations, we did actually get two different numbers, which I thought was kind of interesting because you kind of expect equations to give you all the same data, but that's why we have multiple equations, so we can either check and verify ourselves or get the more accurate number. And then finally went over sigma, which is the exact same formula as the actual standard deviation. However, it's for the population instead of just the sample. And we define the standard deviations as the positive square root of the average squared deviation of a scores from their mean, which was actually what my second question was. I was asking, how did the standard deviation relate to the mean, which standard deviation is just the standard amount that it deviates from the mean or the median. And we went over that further whenever we went over the z-scores, but I'll get to that shortly. We also went over variances, which I don't know why I didn't recognize it whenever I was taking notes, but the variances are actually just the number that we would get before squaring the numbers. So say in the S squared, or the actual standard deviation, the number that we got before we found the square root was 6.97. And so really it was kind of just like backtracking a step to find that. So I did appreciate how simple that seems in theory. But then We also finally went over the z-scores, and I remember going over z-scores quite a bit, just because it's one, typically it went over, it was, excuse me, I spent a long day at work, but it was explained in my general psychology class, like the standard like bell-shaped distribution. We didn't really go over the statistics part of it, but he did explain as like what it meant. And so I made this nice little graph here, as you can see, just explaining what we went over regarding the z-score. And the equation that we had for the z-score was z equals x minus the mean divided by the standard deviation. And if we have a positive z-score, it's going to fall to the right side of the graph. And if we have a negative z-score, it's going to fall to the left side. So overall, a lot of it kind of seemed like it was a review, but it also kind of seemed like you were pulling this information out of like the depths of my mind. So I'll definitely need to just review it, and I think whenever I do the textbook questions, it'll be a lot more easier to understand. But none of it, not that any of it was really confusing per se, but it is a lot of information to take in. And so overall, the lecture from Tuesday was quite informative. You did answer my questions, and you were very helpful towards the end whenever I'd missed some information about the z-scores. So this has been my vlog. Thank you again for answering my questions, and I hope you have a good day. Thanks.